Hello, today I'll be going over an implementation to breadth first search or BFS. If you haven't already, I recommend you watch the previous videos where I talk about BFS as a concept. So first, I'll just set up some input stuff. So let's see, we'll need 10. So the setup will be very similar to the BFS implementation, and I also recommend you watch that because these two graph traversal algorithms are, I guess, very important, and you need to be able to distinguish between them. So, first I'll just take in the input. Okay, so I guess first I'll just describe the input a little bit. So, let me see. So we'll have three, I guess, variables n, m, and v. So n will represent the number. N will represent the number of nodes. M will represent the number of edges, and V will represent the starting node or the parent node. And so our input is going to be something like N and V, and then the next M lines will describe the edges or which nodes are connected to which other node. So if we have something like 4, 5, 1, and 1, 2, 1, 3, just copy the rest. Then, so we have 4 nodes, 5 edges, and then starting point is 1, node 1. We're given that node 1 is connected to 2, 3, 4, node 2 is connected to node 4, and node 3 is connected to node 4. So back to implementation, again we'll take in you actually do need vector. So this vector right here is how we'll keep track of which nodes are connected to what. And I also explain basically the same problem in the BFS implementation video, so I won't be going in as much depth as to how and what I'm coding, so I recommend you watch that first. And then back. So what do I do here? So first in this for loop, we're taking in this input, so m lines of input or 5 lines of input, and we're taking in the nodes that are connected to each other. And then in this vector, we're basically storing for for node x, what it's connected to, this should actually be x, and for node y, what it's connected to. So the vector at index x will have all the nodes it's connected to. The vector at index y will have all the nodes node y is connected to. So that's why we're pushing back y to x and x to y. And then here we'll just sort each vector so that the input is kind of standardized. So now let's start on the breadth first search function. So first we need some integer that represents the node we're currently on. And so for breadth first search, in the concept video, I talked about how we kind of store each layer and what we're going to kind of use to keep track of which node we need to traverse on. So the way we're going to do that is by using a queue. And I have a video about queues, so I recommend you watch that. And the good thing about queues is that it's a first in, first out. So the first element you put in will be the first element that comes out of the queue. And in this way, we can kind of keep track of the layers. Let me draw it out. So for the queue, let's say we have these nodes. We have this graph right here. So you can see here we have, when we're BFS on this, the queue will contain 1, and then we'll push in these two. So the queue will have 1, 2, and 3. And then since the first one to go in was 1, we can now get rid of that. And now we're just left with what is in this current level. And then in the next one, we have to push in what's connected to 2 and 3. So that's 2, 3, 4, 5, 6, 7. And then once we do that, we can get rid of the first two. And then now we're just left with these ones. So in this way, queues can kind of maintain and separate each, layer of the graph in a way that we can kind of traverse layer by layer. So that's why we're using queues here. So first things first, we'll push the integer or the current node into the queue. We'll set visited of this equal to true so that we don't go to it again. And then we'll just have like our current node integer. So while queue.empty is not true. And the reason why we're doing while it's not empty is that as long as the queue is empty, that means there's nodes we haven't visited. And since we're not going to push in anything we've already visited, once the queue is empty, like it is now, that means we've gone through everything. So this is just our way of knowing how to terminate. And so for breadth first search, you might have noticed that this is not a recursive, not like the recursive function we were dealing with the depth first search. It's actually just a while loop. So now we'll set the current node equal to the front of the queue. And then we'll take out front. So when we do queue.pop, it takes out what was pushed in the beginning. So we're effectively getting rid of A. And that means we can move on to the next element. So we get rid of 1, and then now we can move on to 2 and 3. Because in queues, you can only access the first element available. And so getting rid of the front will allow us to do this. The next step is to loop through all the elements in all of the connected nodes to the current node so that we can push it into the queue. So we'll do queue.push, or actually we'll set it equal to, or actually, yeah, we do have to check one condition, and that's if we've already visited the queue, or sorry, the node, then we don't want to visit it again, or else it'll be an infinite loop. So with that, we'll do visited. Set this equal to true, and we'll push it back into the queue so that now we can look at it again. And so essentially what happens is that for each while loop, we'll be checking a node, which is at the front of the queue, then removing it from the queue, and we have a starting cur. And then we loop through all the nodes connected to cur, or the node we're looking at, and then we check if it's visited. If not, then we push it back into the queue. So if 1 is connected to 2 and 3, the process is that we start at 1, so cur is equal to 1, we do queue.front, and then we get rid of 1 so that we don't go to it again. Then in this for loop, we'll loop through all the connected nodes to 1, and then we check if 2 and 3 are visited. They're not, so then we set it equal to true, so we don't double count. And then we push in 2 and 3, and then now we're just left with 2 and 3, and we can repeat the process for those two nodes. And yeah, so that should be, let me actually, okay, so this way we can see what's going on. And yeah, let me, okay. So now we'll run this. Oh, we forgot to call the function. Okay. BFS on B. Okay, so here we can, I just like outputted how the graph traverses, so it goes from 1 to 2 to 3 to 4. So if we try to like visualize what's going on here, we're given that the input is we have, so 1 is our parent node, and then we're connected to 2, 3, 4, and then we're also given that 2 is connected to 4 and 3 is connected to 4. So how does this work? So the BFS first looks at parent node, which is our first, and then it looks at all the child nodes. So we have in the queue, in the beginning we have 1, and then we have 1, or sorry, then we get rid of 1, so there's nothing in it. I'll just do it step by step. Okay, so first we have 1, then we pop 1, so 1 is no longer there, and then we for loop. We do a loop on everything connected to 1, so we have 2, 3, and 4, so we have 2, and then 2, 3, and then 2, 3, and 4. Oops. So yeah, and then we'll go through the top of the while loop, and we'll go through everything that's connected to these nodes. But as you can tell, we've already visited all of them, 1, 2, 3, and 4, so it's actually just going to end right there because we visited all the nodes, there's nothing else to go through. So first we traverse through 1, then 2, then 3, then 4, so the output should be 1, 2, 3, 4, and we can see that with our answer here. So this is just a basic implementation of breadth first search. There's a lot of variations and you have to modify it to the problem you're solving, but yeah, that's basically it, and thank you for watching.